Hello. In this third video about instance methods, I'll examine drawing app 1.2 under the hood by demonstrating the mechanisms of invoking instance methods. So the code I'll demonstrate is what I've discussed in the hands-on. So I have the rectangle class with two methods, the print method, which I'm not going to use in the next versions, but I still want to demonstrate the invocation of this method because it doesn't return anything, and so I can compare with the invocation of toString method that does return something, namely a reference to in this case, a string object. So first of all, an examination of the invocation of the print methods, and after that, the invocation of the toString methods, returning a reference to the string objects. Okay, so the memory layouts. What I'll demonstrate first is what I've covered in the very first under the hood video about instance member variables. So I'll demonstrate it more quickly. If this goes too fast for you, I kindly suggest you watch that video first. First of all, the declaration of the reference variable rect1 on the stack. Then the creation of the object on the heap with default values for x, y, height and width of 0, located at a fictional address 1000, and the assignment results in rect1 having the address of the object, so rect1 refers to the object on the heap. Then rect1.x, so the x field receives a value of 10, the y field the value of 20, height value of 100, and width value of 200. Okay. Now what happens when we invoke a method using the reference variable? Well, while this statement rect1.print is located in the main method, so the current stack frame is that one of that method, the main methods. When invoking another method, a new stack frame will be constructed, this time for the print methods. What will be part of the local variables array in this case? Well, because it is an instance method, and the instance being used is rect1, well, the value of rect1 will pass to an automatically added variable called this that will contain a copy of the rect1 value. This will result in this reference variable referring to the same object. We call this the this pointer. And this allows then to access that object from a different location in the code memory, namely the print method. So print has now access to that object. Okay. The stack frame for the print method is now set up because there are no parameters. What happens now? Well, system.out.printf, which will result in the output of x equals, and then the value of this.x. This.x, well, we start from the this pointer, we follow the arrow to have a look at the object at address 1000, and we want to print out the content of the x field, so 10. So this entire statement results in the rectangle class printing output to the console. As demonstrated in the hands-on video, it is a bad practice because library classes should never print information to the console. Now, the output here is a bit limited because I don't have enough space to mention here as well the properties y and height and width. Once this statement executed, we're done. Execution resumes in the main, so the virtual machine doesn't need the stack frame of the print method anymore, and control is set back to the main method using its stack frame. That for the execution of the print method. Now, what happens when we execute the toString methods? So first of all, I define a reference variable rectinfo, and that one will be located on the stack of the current stack frame and the main method because we're back in the main method. Rect1.toString then results in the invocation of the toString method of the rectangle class. Invocation of a new method means that its stack frame must be set up, and that stack frame will then become the current stack frame. As with the previous invocation that I demonstrated with the print methods, so first of all, the value of the rect1 variable we are currently using will now be copied to the implicitly added this reference variable or this pointer to the stack frame of the toString method, resulting in the this pointer referring to the same object. And so this gives the toString method access to that object. And then the execution of the statements. Return string.formats. First of all, string.formats is executed, containing similar information as what we've printed to the console in a print method, but this time that information is located in a new object that will be allocated on the heap. At a fictional address, address 2000, and it contains the following characters, so x, the equal sign, and 10. But this is a string object. What are we going to do with it? We're going to return its address. So implicitly, a new variable will be added to the local variables array of the current stack frame. So I give it the label return value, and it contains the address of the string object we just created. That's all for the toString method invocation. Now, control will be back in the main methods, which will assign the result of the toString invocation, namely the value of that return value, assign it to the rectinfo local variable within the main method. So now we have the value of 2000, which is copied to the local variable within the main method. And so rectinfo refers to that string object. Control will now resume within the main method, so the stack frame of toString is not necessary anymore, and the virtual machine uses the stack frame of the main method. Second statement was then the printing out of rectinfo, which results in printing out information to the console. Note the difference though with the print method. In the demonstration of the print method, it was the print method which is implemented in the rectangle library class, printing that information to the console, which again is bad practice. In the toString scenario, on the other hand, it is the client which is printing the information to the console. We're doing this because Drawing App is a console application, but in case the client would be a graphical user interface program or a mobile app, the rectinfo would be displayed on the screen using a different mechanism, so not by printing out the information to the console. This for the under the hood demonstration of instance methods. Thank you for watching. Bye bye.